What happens when a frozen world locked away for millennia starts to thaw and a helicopter crew flying over Siberia discovers something mysterious? A crater more than feet wide and deeper than a story building. Sinkholes are nothing new, but this is no ordinary sinkhole. The ground has exploded. There is no way this is not real. More Siberian craters have since been discovered. There is even evidence they may be appearing in Alaska. The lake bottom went from being flat, and then it just dropped out, and they show no sign of stopping. Now scientists from around the globe race to understand a hidden world. I'll buy permafrost, a layer of frozen earth spanning a quarter of the northern hemisphere's land mass. This ancient freezer is beginning to thaw, revealing its deepest secrets. Pretty exciting. This is a mammoth bone right here, releasing over half a tons of carbon every year. It was just insane. Like the water is boiling around you and threatening local communities. Houses need to be torn down. We are in the middle of a housing crisis. Are the craters warning shots for our climate future that is not included in climate models? That's a scary wild card in the climate change story. What new dangers lurk beneath this vast frozen landscape, and could they warm our planet even further? Arctic sinkholes right now on Nova, the Yamal Peninsula, Siberia. Square miles of freezing tundra located in northern Russia. The Yamal lies well above the Arctic Circle. It's home to around indigenous Nenets people, most living as nomadic reindeer herders, and their language Yamal means end of the land. It's now beginning to look like it. Giant craters were spotted in the north of Russia. They popped up out of nowhere in the Yamal Peninsula. When I first heard about the crater, I didn't believe it. I'd actually thought it was a made-up story. Believe me, I remember this date, and I will remember it forever because it was absolutely exciting, something I have never seen before. The mysterious crater is a feet deep, filled up with rainwater. Its volume is greater than Olympic swimming pools. The striking images go viral worldwide because no one can answer what caused it. Vasily Bogoyevlensky is an expert on the geology of the Yamal. With other scientists, he choppers out to the scene. When we just came to this crater, of course we didn't know for sure what was there. We never saw something like that. Never. This isn't the first massive pit to open up across the world. Gaping sinkholes have appeared due to water or erosion weakening the ground beneath, swallowing cars whole and wreaking havoc in towns and cities. But while the Yamal crater looks at first like an ordinary sinkhole, there's something unusual visible around the edges. Most sinkholes have a rim that is flat, not raised. And while sinkholes collapse inwards, the team discovers debris spread far outside the crater. Pieces of rocks and ice are flying, sometimes in quite a long distance, from meters to meters, and in one case it was distance to meters. Debris like this can be thrown out by the impact of an asteroid, but there are no other signs of a massive object striking Earth. For the scientists, that leaves only one reasonable explanation: a gigantic natural explosion. I don't know if there are many Earth system processes that have never occurred. I mean in my lifetime, or at least to scientific understanding, that have never occurred and that we are starting to see as a new process. So what could have provided the power for such a massive blast? There is no sign of lava or volcanic rock, so this clearly isn't a volcano. But exploring inside the crater, sampling the air and water at the bottom, the scientists do discover an intriguing clue: unusually high levels of a single gas, methane. Used for cooking and heating, methane is a flammable gas made from carbon and hydrogen. When combined with air, it ignites easily. So this is huge bomb, methane bomb. But before scientists can determine where the methane came from, more giant craters are discovered. Investigating scientists find new evidence of methane, since at least confirmed craters have been found on or close to the Yamal. But the growing number of craters isn't the scientists' only concern. They notice a climate connection. When the first crater appears, followed one of the hottest years on record in Russia. And all the craters are discovered during a period of uncharacteristically warm weather in Siberia. Since the late century, the average global temperature has risen around degrees Fahrenheit, but the Arctic is warming faster. It's currently heating up around twice as fast as the rest of the planet. The scientists begin to ask, could explosive craters be connected to climate change? If so, what might they be telling us about Earth's climate future? While scientists on the Yamal study the crater elsewhere in the Arctic, another team is about to discover new pieces of the puzzle, this time in Alaska. Kotzebue, near Alaska's northwest coast. In a local pilot reports a lake that's behaving oddly. Now a team of scientists that had been investigating returns to the site to continue its work. So we just left Kotzebue and then we crossed the Kotzebue Sound and into the mouth of the Notek, which was this beautiful sweeping landscape. Far from the nearest town lies Easy Lake. Easy Lake is located on the lands of the indigenous Inupiat people. The state is home to over 13,000 Inupiaq people whose traditional lands stretch across northern Alaska. One of the scientists on the team has special ties to this community. In 2017, Sharp and other scientists asked the local community to help them identify unusual features in the wilderness. A pilot named Eric C. told them that while flying over the area he'd spotted something unusual. On their first visit, the team wanted to investigate what's causing the bubbles. Methane leaks known as seeps have been found elsewhere in the Arctic, but they are usually much smaller. The team's measurements reveal that Easy Lake is belching out over 10 tons of methane every day. The team decides to get closer to the source. Sullivan finds that the lake is shallow, just a few feet deep, but then he follows the lake floor towards the source of the bubbles. Sullivan finds the methane bubbles are streaming up from the hole in the lake floor. With the lake bottom too dark to see, the team deploys a sonar scan. Most of this bed is around 3 feet deep, but beneath the streams of bubbles the ground abruptly falls away, at its deepest reaching 50 feet. Why does a lake floor otherwise flat and shallow contain such a massive hole? On the Yamal, scientists believe a methane leak blew out a huge crater. Easy Lake is another sign within the Arctic that beneath the surface methane is stirring. So could more craters and more methane be on the way? As well as methane, there's one more clue that links Easy Lake and the Yamal craters. Both are located on the same type of frozen terrain, permafrost. Most permafrost is found in the landmasses of high northern latitudes, including Russia, Canada, and most of Alaska, covering an area almost as large as the US and Canada combined. Permafrost can stretch almost a mile beneath Earth's surface. It's defined as any ground whose temperature remains at or below 32 degrees Fahrenheit for 2 or more consecutive years, but it can remain frozen for millennia. Recently rising Arctic temperatures have meant that in some regions the permafrost has started to thaw. Just how fast and the danger this may pose to our climate is revealed 450 miles from Easy Lake. Near the town of Fox in interior Alaska, something strange is happening in the woods. This forest sits on top of permafrost. Scientist Tom Douglas has been tracking some surprising changes taking place as the permafrost starts to thaw. This rapid thaw is also affecting human settlements like Utqiagvik, the most northern city in the United States. This entire community sits on top of the Alaskan permafrost. Locals call it the top of the world. Gordon Brower is a native Alaskan Inupiaq whaling captain. His people have lived in this region for 1,000 of years. For 5 decades Brower has been hunting in these waters, part of an ancient Inupiaq tradition of living off the land and the sea. With little fresh food available in winter, generations of native Alaskans have depended on cellars carved out of the permafrost. But thawing permafrost means this natural deep freeze isn't as cold as it used to be. As Brower discovered, thawing ice cellars aren't the only threat rising temperatures pose to this community. Recently, sea ice that used to protect the shore from storms has begun to melt. Exposed by the storms, permafrost is thawing and crumbling away. Now communities like Utqiagvik are trying to protect their homes. With a retreating coastline and warming ice cellars, local communities are hit twice by thawing permafrost. But the big thaw is an Arctic-wide problem. Through the next decades and century, we expect anywhere across the Arctic between 30 to 70% of near-surface permafrost will be lost. Arctic communities are facing the immediate effects now, but scientists are concerned this loss has implications for the entire planet. So why is permafrost thaw so dangerous? And what is the link to methane? Back near Fox in interior Alaska, Tom Douglas is about to do something only possible in a few places on Earth: walk deep down into the permafrost itself. The Fox Permafrost Tunnel reveals there's more to permafrost than frozen Earth. The tunnel reveals that permafrost contains vast quantities of organic matter. This ancient organic matter, like all life on our planet, contains carbon and is part of a vital Earth system called the carbon cycle. As they grow, plants absorb carbon dioxide. When they die, they or the animals that have eaten them decompose, releasing some of this carbon back into the atmosphere. But in the freezing Arctic, decomposition happens slowly. So over millennia a huge amount of organic matter became permafrost before it could decompose its carbon, frozen in time. In the late 90s into the 2000s people start to look at the stocks of carbon and permafrost, and it's a lot. It's about 1.4 trillion metric tons. It's almost twice as much carbon as is currently in Earth's atmosphere. When we walked in we noted that smell right, you're smelling ancient bacteria and carbon being oxidized. It's almost like a well. It's I've heard anything from, like, a French cheese to barnyard. But it's kind of that organic, almost a late fall wet leaf kind of organic smell. You are smelling permafrost carbon being oxidized. And so the big question is that carbon that we smell that's all over this tunnel walls, what's its ultimate fate? And there's a lot of people working on that. In other words, how much of this carbon will end up in the atmosphere, and most importantly, how fast? Falmouth, Massachusetts, 3,000 miles from the ice tunnel, Arctic ecologist Susan Natale investigates samples of permafrost to find out what happens when it thaws. So these are permafrost cores that were collected from different locations across Alaska. Some of these are really dark, like particularly this one, and that dark color means that has a lot of carbon in it. As permafrost warms, its carbon thaws, and the carbon cycle starts up once again. So that carbon then is available for microbes to break down. And they use it for energy, and they decompose it. And in that process, they're releasing carbon dioxide or methane. Carbon dioxide and methane are both greenhouse gases. As Earth's surface absorbs energy from the sun, it radiates some of it back out as heat. In the atmosphere, greenhouse gases absorb this heat, radiating part of its energy back at Earth and heating up our planet. Greenhouse gases are a concern because they trap heat. They're helpful to us because they make this habitable planet, but because there's too much in the atmosphere, they're now making this an inhabitable planet or a less habitable planet. It's estimated that in the mid-18th century, there were over 2,000 gigatons of naturally occurring carbon-based greenhouse gases in the atmosphere. With industrialization, human-made greenhouse gas emissions began to add to this amount. By 2019, it's estimated the total had risen to over 3,000 gigatons. Over the last century and a half, Earth's average temperature increased around 2 degrees Fahrenheit. Scientists agree human emissions caused this warming. But recently, they've become concerned greenhouse gases being released by permafrost might be driving temperatures higher too. As the name suggests, permafrost is permanently frozen ground. So we thought, okay, this carbon is very stable, so nothing is going to happen. But as permafrost starts to thaw, this carbon becomes vulnerable. Since the mid-70s, carbon dioxide emissions from the North Alaskan wilderness have spiked by more than 70%. But while we know a lot about carbon dioxide, the impact of another greenhouse gas coming out of the permafrost is less widely known, the very one escaping from the Yamal and Easy Lake, methane. Methane is really important because it's much more potent in terms of its ability to trap heat. So it's about 30 times more powerful than carbon dioxide. Luckily, while carbon dioxide lasts centuries or longer in our atmosphere, methane only lasts around 12 years. But as a far more potent greenhouse gas, any large-scale increases in methane emissions have climate scientists seriously concerned. For now, more than half of methane emissions come from human sources like fossil fuels and agriculture, sources well understood by climate experts. But scientists are increasingly worried about methane emissions from permafrost. So far, they don't know how much methane the permafrost is releasing, and that's a big problem. In order to control our temperature, we have a certain amount of carbon that humans can release. That's our carbon budget. In 2015, the International Paris Agreement set a target for limiting global warming. Its goal was to keep the temperature rise to well below 2, preferably to 1.5 degrees Celsius. To stand a good chance of remaining below the 1.5 degree mark, one estimate states that humans could release a maximum of around 460 gigatons more carbon dioxide. But recent climate calculations are based on computer models with incomplete information. Unfortunately, a lot of these Earth system models that contribute to such goals do not take into account CO2 and methane emissions from permafrost. The most recent carbon budgets have started to include permafrost carbon, but some scientists believe they still underestimate the amount of carbon the warming Arctic will release, making temperature goals harder to meet and putting more pressure on societies to dramatically cut their emissions to compensate. So we think we have a certain amount of greenhouse gases that humans can release, but our target is wrong right now because we're not accounting for potential permafrost emissions of methane and carbon dioxide. Understanding the dynamics of thawing permafrost is now critical to predicting our climate future. So how much methane is permafrost emitting each year? And is this annual amount going to increase? Head, dog. Head dog. Stay ahead. Come back. Come back. Come back. Fairbanks, Interior Alaska. Ecologist Katie Walter Anthony is heading out onto the frozen terrain. Come on, Pete. Come on. Walter Anthony was among the first to study Easy Lake. She's found concerning evidence it's not the only lake in the permafrost region that's releasing methane. So when you spear the spot, if I hear gas coming out, I'm going to try to ignite it. And if there's fire, we both need to get out of the way. Okay. Ready? Yep. Whoa. That got me. Oh, shoot. Am I on fire? No. I was wondering. What's smoking? You okay? Yeah. I'm alright. What? That was a good one. That was a good one. Alright. The methane comes from organic matter and permafrost thawing and decomposing at the bottom of the lake, then rising in methane bubbles to the surface. Across the Arctic, permafrost thaw is generating vast numbers of new lakes. As the soil warms, ice beneath the surface melts, causing the ground to slump and fill with water. And once a lake is formed, you can't stop it because that water has heat, and it causes the ground to thaw so fast. The lakes then start releasing methane. As the methane escapes, it causes more permafrost to thaw and more methane to be generated. As permafrost thaws, greenhouse gases like CO2 and methane will be released back to the atmosphere much faster. Warming is causing more warming. Due to positive feedback, permafrost emissions could increase the rate of warming, compounding the need for humans to reduce their emissions if climate targets are to be met. But permafrost carbon isn't the only potential driver of a positive feedback cycle. Permafrost is actually not the largest carbon reserve on Earth. There's much larger carbon reserve in Earth's crust as fossil carbon, but we often don't talk about this carbon. This is because this carbon is considered very stable. But some scientists now wonder if this megasource of carbon is as stable as they thought. Disturbing evidence comes from the bubbles in Easy Lake. Methane released by thawing permafrost has a particular chemical fingerprint. When the scientists at Easy Lake studied the methane in the bubbles, they discovered it originated deeper inside Earth, much deeper. Miles beneath the permafrost, deep in Earth's crust, lie huge fossil methane reservoirs. While methane from permafrost comes from organic matter thousands of years old, fossil methane comes from organisms that decomposed millions of years ago. But if it's miles beneath the surface, how is this methane getting through Earth's crust, and why here? Above ground, the landscape itself gives scientists a clue. Looking up at the peaks around here and studying the local geology, we know that this is a highly fractured and faulted region. As of 2021, Alaska is the most seismically active state in the U.S. In the territory close to Easy Lake, scientists have discovered a network of geological fault lines. Movements of Earth's crust have caused it to crack here. The closest fault line discovered so far is fewer than 5 miles from the lake. Fault lines make cracks in Earth's crust through which fossil methane can rise to the surface. Though it hasn't been confirmed, the scientists suspect a fault line lies near or directly beneath Easy Lake. But if so, there's a mystery. Seismic evidence from the area suggests Easy Lake sits above 500 feet of still frozen permafrost. This should form a rock-solid frozen barrier trapping the fossil methane inside Earth. So how are these deep stocks of greenhouse gas breaking through to the surface? So far, the team's sonar scan has revealed a 50-foot hole in the lake floor. But what if they could look deeper into the permafrost itself? Geophysicist Nick Hassan joins the team with technology used by the military. I'm essentially scanning the permafrost using a geophysical method called very low frequency. Very low frequency, VLF, measures a special kind of electromagnetic wave as it moves through Earth. These waves are sent out globally by the Navy to communicate with submarines. But as those waves pass through the Earth below, Hassan's equipment can pick them up. By measuring the speed the wave travels, Hassan can tell whether the ground deep beneath him is frozen or not. When it moves through the ground, if there's permafrost or ice, these waves are coming up against a lot of resistance. But if there's no permafrost or ice, it quickly moves through. If they're strong enough, the electromagnetic VLF waves should enable Hassan to see whatever lies beneath the lake. Easy Lake is the biggest on-land methane seep yet found in the Arctic, but no one has used VLF to look beneath it until now. Back at camp, Hassan takes the first ever high-resolution glimpse beneath Easy Lake. This slice through 500 feet of ground below the lake reveals an anomaly. So the dark blue is the permafrost region. So anything that's light blue to red is thawed. And so this shouldn't be here. There should be permafrost covering this entire area. But for some reason, what you can see here is a thawed chimney going from somewhere below 150 meters to the surface where we see the rising bubbles, and so this is really unique. So far, the scientists have only seen 50 feet beneath the lake. Now Hassan's VLF image lets them look 10 times deeper. Below the lake stretches a deep layer of permafrost, but the scientists now know this hasn't just thawed at the surface. Instead, a chimney of material has thawed right through the frozen permafrost, a warmer, semi-permeable passageway through which fossil methane rises to the surface. So thawing permafrost means not one, but two sources of methane for our atmosphere. As it warms, permafrost releases its own methane gas. And as thaw chimneys form within it, they provide an escape route for fossil methane that has been safely trapped for millions of years. Scientists estimate there are around 1.3 trillion tons of methane stored beneath the Arctic. That's nearly 250 times as much methane as there is in Earth's atmosphere today. While the leak in Easy Lake is unusually large, smaller seeps of fossil methane are being discovered across the Arctic. In Alaska alone, over 70 sites have been found. There's no current sign the entire reserve of fossil methane is moving toward the surface, but the appearance of even small amounts of this ancient greenhouse gas has some scientists concerned. If permafrost thawed, then that's a scary wild card in the climate change story because we think there's a huge amount of methane and natural gas trapped inside permafrost and under permafrost. So if permafrost becomes like Swiss cheese with lots of holes in it, then you can have chimneys where that gas is erupting out, and that is not included in climate models. If only a tiny fraction of the fossil reservoirs were to reach the atmosphere, it could intensify warming, putting even more pressure on human emissions targets. Scientists don't currently understand how fast such a cycle might occur or what it would look like. But there's one place on Earth that gives a chilling example of how a human-made permafrost feedback cycle actually works. A stretch of forest was cleared to make a road. Stripped of its tree cover, the permafrost was exposed to the warming sun. As it thawed, the ground sank, pulling down trees at its edge and exposing more permafrost, a positive feedback cycle. Today, the strip of cleared forest is a depression nearly 300 feet deep and over half a mile wide, and it's growing. Scientists call it a mega slump. Batogaica is very big, but this size is because of the initial human impact. And this one is already more than 1 kilometer and growing every summer. Batogaica reveals how a small human impact can start a devastating feedback cycle in permafrost. Scientists are now trying to discover what a feedback cycle could mean for the entire permafrost region and whether it could reach a point where it becomes irreversible. Such a phenomenon is called a tipping point. A tipping point is the proverbial straw that broke the camel's back. You can get away with adding straw for so long, and then you can't. The tipping point is the point of no return. It's a controversial idea among climate scientists, but the prospect of a tipping point has been raised for a number of global climate systems, including Arctic sea ice and deforestation in the Amazon. So far, there's no conclusive evidence that a tipping point is near for permafrost. However, some scientists believe aspects of the thaw are now irreversible. Vladimir Romanovsky has spent decades studying the changing permafrost. Near Reykjavik in northern Alaska, he investigates what happens as large wedges of ice in the ground start to melt. Romanovsky believes lakes formed by melting permafrost ice have passed a point of no return. It took tens of thousands of years to put this ice into the ground. Now it's melting. To put all this ice back into the ground, you would need several tens of thousands of years. So that's, for humans, definitely an irreversible process. It is a tipping point. While melting ice forms lakes in the wilderness, just a few miles away, it's causing very different problems for the local community. In the roads outside of Reykjavik, the effects of rising Arctic temperatures are easy to see. Just from observation, growing up here, coming out here since I was a kid, the roads were a lot higher than they are now. It is literally sinking. His bumper might get wet. Native Alaskan Inupiaq Lars Nelson is an infrastructure consultant. He knows firsthand what permafrost thaw is doing to his community. This road is for subsistence use. We come out here and stage our hunts. It's a big part of our history, and it's important that we're able to access it in case of an emergency. And it's not just the roads that are sinking. In downtown Reykjavik, Nelson meets Inupiaq Anthony Edwardson. These ones are subsiding too. Yeah. That's where the houses are sinking. Local houses are built on wooden pilings. If they were built on the ground, the heat used to warm the homes would thaw the permafrost below. But now the permafrost is thawing by itself, and the pilings are starting to sink. When the piling is a very small base, it doesn't hold its structure. Communities need the house leveling, move houses. Houses need to be torn down. We're in the middle of a housing crisis. Nelson believes strategic building is the answer. We're onto it right now and we're refining it right now. We can build nice, good, healthy homes. We just gotta pay attention to our foundation, pay attention to the tundra we're building on more closely because it's such an awesome spot, you know. It's the top of the world. But as the permafrost continues to thaw, others in Alaska are looking at more drastic solutions. CEO of the Regional Housing Authority, Griffin Hagel, has a more radical plan for sinking homes. So this is our portable, adjustable, flood-based home. It is on a giant steel sled as opposed to pilings. What we would do if we needed to move this, we would be hooking up our tow chains to these two attachment points. We've got one on this side and one on that corner of the building over there. Hook that up to a piece of heavy equipment, Caterpillar, and then drop it off the pads and basically tow it across the snow in the wintertime. As temperatures rise, Hagel is searching for ways to protect some of the most isolated communities in the United States. This is the largest municipality in the world, I think, by land area, and we provide affordable housing in 8 villages across an area the size of Minnesota only without any roads. No Alaskan homes have been sledded away yet, but Arctic warming has forced some towns to relocate, and Hagel thinks houses will soon be on the move. And there are several, communities, especially in rural Alaska, native communities, that are increasingly at risk of relocation due to global warming. And so this gives us an advantage in having the option, the adaptability to move that structure if it becomes necessary. Native people, the indigenous communities that have called this place home for thousands of years, have come up with all sorts of innovations to make life work here. So we draw a lot of inspiration from that, and we see that as kind of the continuation of the long tradition of innovation. As inhabitants across the Arctic adapt to their changing world, scientists strive to build a better picture of our climate future. The methane craters are just one sign of a region undergoing unprecedented changes, placing communities with deep ties to this land at risk. We've been whaling here for well over 4,000 years. We've adapted time and time again. Today, we might not be able to do it by ourselves. But the big thaw is not just a regional problem. What's happening in the Arctic could really affect everyone on Earth. Arctic greenhouse gases will intensify future global warming. How quickly is difficult to predict, and positive feedback cycles could accelerate beyond human control, making our choices today even more urgent. Because it's very difficult to take control over the natural systems, it's even more important for us to lower our emissions. These craters are a really important and concerning indicator that things are changing, and the Arctic is melting, and the future of the Arctic is a very different place than it was several decades ago.